Today we're going to be talking about equilibrium of forces. Okay, so hari ini, as you can see, my hands are free because we're only using PowerPoint. I don't think I need to draw anything because everything is in a PowerPoint. And today we are going to talk about how to, number one, properly draw a diagram, a free body diagram where the forces are in equilibrium. Okay, and then secondly, once you draw the triangle, okay, it's a triangle also lah. Okay, once you draw the triangle, you also will have to know how to calculate everything that is in the triangle. Okay, so we're going to take stuff from maths and a little bit of physics in today's lesson. Okay, so this is Malay. So there's this photo that's showing you situations where forces are in equilibrium. Okay, so look at the guy that is doing literally a handstand on a head lah. Okay, they're obviously not moving anywhere and they're all totally balanced. No one is falling over. Okay, so this is a situation where you see that they are actually in equilibrium. Okay, so get used to this word now. The word is called equilibrium because when forces are in equilibrium, okay, the resultant force is zero. I repeat, when forces are in equilibrium, okay, when all the forces are in equilibrium, okay, the resultant force must be equal to zero. And we saw this in the first part of our chapter this year. Okay, so if let's say you have a book on the table, and we have learned that whatever object that is on the table or this one, there's always two forces. The number one force is always the weight of the book. Okay, and the weight of the book is caused by what? Somebody just answer. What is the weight of the book caused by? What is causing the weight of the book?
Gravitational force.
Very good. Gravitational acceleration, but okay, we can call it gravitational force. Okay, sorry, I cannot see your chat. I can only see you and I can only see the slide. So you kind of have to unmute yourself to answer. Okay, so the weight is caused by gravitational acceleration. We studied this before. And the reaction force, because Newton's third law tells us that every force must have a reaction force. Okay, and because the weight is going downwards, the reaction force is upwards. Okay, from the table onto the book or from the table onto the pasu bunga. Okay, so it is the same magnitude, okay, just in a different direction. And we find that because the weight and the reaction force is the same value, okay, both of these forces are in equilibrium. Okay, so sorry, this is Malay. Sekejap saja dalam bahasa Melayu, okay. So keseimbangan daya, bila daya paduannya adalah sifar, when the resultant force is 0, 12 minus 12, okay, you get 0 lah. Okay, so when the resultant force is 0, this is a situation where we call the forces are in equilibrium. Okay, oh my word. Okay, so this is the word, equilibrium. All right, take a note of how you, take a note of how you spell the word equilibrium. Okay, equilibrium of forces. So there are two situations where the equilibrium of forces occurs. Number one, as I said before, when the resultant force is 0, okay, the object is either at rest or is moving with constant velocity. We have established this very early on, okay, and I just want to mention this again. When the resultant force is 0, the object is either resting or it can be moving with constant velocity. What is the friend to constant velocity? Shafiq Iqbal. Can anybody tell me what is the friend to constant velocity? What is the other meaning of constant velocity? Uniform
stationary.
What? No, stationary is at rest. Come on, it is moving. It's not stationary. It's moving, but with constant velocity.
Uniform acceleration.
Pun salah. Come on, constant velocity.
Acceleration.
Zero acceleration. Okay, uniform acceleration means the velocity is increasing. Oh dear. Okay, I have to repeat this sampai ke jana ini saya rasa. Okay, constant velocity is zero acceleration. There's no acceleration. That's why the resultant force is 0. Okay, we covered this guys. Okay, don't forget. Okay, so let's say you have this thing. This thing is called spring balance. Okay, so this thing is called spring balance. Not really readable here, but let's say the weight of the load is 3 newtons. Okay, now what is the force acted by the spring balance on the load, and what is the direction of the force? Okay, so the force is obviously 3 Newton. Okay, and we find that there is a force pulling it upwards, which is caused by this string. Okay, this string is pulling the weight upwards. Okay, with a force of 3 Newton also. And so we find that the weight yang ke arah bawah equals to the dalam bahasa Melayu is tegangan. What is it in English? Tension. Okay, the tension that is going upwards because there's a string. Okay, and so because of that, the forces are in equilibrium. So this is another example that actually we've seen before. Okay, cuma I want to try to refresh your brain before we go into the proper stuff lah. Okay, when up equals to down, okay, and the object is either not moving or is moving with constant velocity. People, I've already said this many times, constant velocity or zero acceleration, moving. Okay, the forces are in equilibrium. Okay, so this is the second situation. A wooden block moves with a constant velocity when it is pulled by a force. Okay, so this is very important. So when it is moving with a force, okay, there is the friction behind lah. Okay, obviously. And then of course, there's always going to be a weight and a reaction force. Okay, so the question is, what is the resultant force on the block? Jericho, why don't you tell me, what is the resultant force on this block?
0.
0. Okay, thank you. State the relationship between the force and the friction. Michelle. Sorry, is Michelle here?
They are in equilibrium.
Okay, so the force, the force and the friction are actually equal to one another lah. Okay, they are in equilibrium. And likewise, the weight and the normal reaction will also be the same. Sorry, I don't know why this slide is in English, but the answer is in Malay. But I think, yeah, can lah kan. So, do the forces on the object move with constant velocity? Sorry, do the forces on an object moves with constant velocity are in equilibrium? Oh dear, sorry, I'm not sure what this is supposed to mean, but I think the answer is yes lah. Okay, so when when forces are in equilibrium, this second thing that I need you to understand, we've established this last time, but I want you to really understand this. Even when forces are in equilibrium, it doesn't mean that the object doesn't move. Okay, it can also mean that the object is moving with a constant velocity, alias zero acceleration. Okay, so be aware where the two situations of resultant force equals to 0 or forces in equilibrium. Okay, these two actually mean the same thing. Resultant force equals to 0 or forces are in equilibrium simply can be either the object is stationary or the object is moving but with a constant velocity. There is no acceleration. The only way that it is not in equilibrium, means one force is bigger than the other, is if there is an acceleration. Okay, which we established long time ago, like feels like a long time ago, like this Chinese year kan. We established with this formula, which is F equals to ma. The resultant force equals to the mass times acceleration. If the resultant force is 0, acceleration will be 0. Okay, which means that it moves with a constant velocity. Dia bergerak, cuma dia tidak memecut. Okay, the important difference is there lah. Okay, so diagram show below situation when forces are in equilibrium. Show and label the forces acting on the object. So since all this is in equilibrium, I don't really want to waste too much time. Okay, so otherwise you'll be like just saying the same thing, because actually this is not even the real thing in this chapter, in this subtopic. Okay, so forces in equilibrium, because one is 2, one is 2. Okay, what about this one? Are these forces in equilibrium or not? Obviously it's not lah. Okay, because the resultant force is 2. There is a resultant force that is not 0. So that means the forces are unbalanced. It is not in equilibrium. Equilibrium means keseimbangan, dan dia tidak seimbang. Okay, so when there is a resultant force that is not 0, then we call this unbalanced force. Okay. Situation C, all you know is the car is moving with constant velocity. The moment kamu nampak constant velocity, you know that the forces are in equilibrium. Okay, so be careful of this word. Okay, constant velocity and stationary. Because they mean a lot of things, Okay, dia bukan sekadar okay dia bergerak bah. Okay, but there's a lot of things that make it supaya dia bergerak dengan constant velocity. Okay, be careful about that. Okay, sorry. Okay, so now we are given this situation, and this is the thing that we need to learn today. And this is why I need you to, this is why I need you to have the whiteboard ready lah. Okay, so this is a situation where this load over here, yang 15 kilograms, sorry, I don't know if you can see my pen, but I think you should be able to lah kan. Okay, so you see this 15 kilogram punya load, it is in equilibrium, it's not moving anywhere. Okay, but it is being pulled by 3 separate forces. Okay, the number one force is because of this tension, TENSION. So T1 is this tension from the rope because dia sedang ditarik oleh this what is this thing called, a hook lah, okay, a tempat sangkut lah. The second force is probably somebody pulling it to this direction. Okay, so somebody is pulling this lah. Okay, and then of course, because it's hanging in the air, there has to be this third force, which is the weight. Okay, and the weight actually shouldn't be 150, right? The weight should be actually how much? Can anybody tell me? How much should the weight actually be? Not 150.
147.15.
Okay, 147.15. So I'm just going to write this there because I have a feeling that after this, the calculation will all be like weird, but never mind. Okay, so 147.15 newtons. Oh, this is so suffering. Okay, so how do we determine T1 and T2? I need to know how to calculate T1 and T2. Okay, so the first thing we need to understand is that it is equilibrium. Okay, all these 3 forces are in equilibrium. The thing is not moving, but there are 3 forces that are acting on the load. Okay, and we can represent this by drawing a triangle of forces. Okay, so I repeat, there are 3 forces acting on this, and since it is in equilibrium, we can actually find the value of T1 and T2, okay, by drawing a triangle of forces. Okay, so our first task today is how to draw the triangle of forces. Okay, so, oh no, the graph. Okay, so a triangle of forces can be drawn to show the equilibrium of forces acting on the object. The magnitudes of the 3 forces are represented by the lengths of the sides of the triangle, and they are drawn in sequence according to the directions of the force. So we need to take into account ini arah apa, ini arah apa, ini arah apa. T1 is like a little bit sengit, okay, T2 is to the right, and the weight, okay, 147.15 newtons is to the down lah, okay, ke bawah. Okay, so first thing you draw the 150 newtons, and then the T2, and then the T1. So this is what you'll get. If you draw from a starting point, okay, then you draw the 150 newtons down. Okay, same direction lah bahkan. Do you see this? Okay, and then after that you draw the T2. Apa yang kamu kena buat is kamu perlu sambung. Okay, so the 150 newtons ends here. Then you follow with the T2, same direction. This T2 and this one is the same direction, T2. And then you complete the triangle by drawing the T1. Okay, notice that the T1 and this red color arrow is the same, well, pretty much the same direction. Okay, T1. And you know that the angle between T1 and the straight line down right over here, okay, is about 30 degrees. So you can put it there. Okay, that's why this 30 degrees is over there. Okay, so you kind of have to imagine that these 3 forces, right, you can actually tarik diorang kan supaya membentuk satu segitiga yang bersambung. Okay, so this is the difference between this subtopic and the 2 subtopics ago. Okay, I will cover this in a little bit. So we can calculate T1 and T2 by using trigonometry. Okay, can anybody suggest to me how would you find T1 and T2? Whenever you see a triangle and you kind of know that this is a 90-degree kan, what must we think of?
Guna sine rule.
Sine rule, no, I don't think I want to use sine rule. Okay lah, fine. I can use sine rule lah, but I don't have to use sine rule. Any other suggestion? Okay, so actually what you can do is you use sine 30 lah. You have this angle 30 ma. Sine is opposite over hypotenuse. Okay. Oh, this is salah sudah ni. It shouldn't be sine 30 kan. It should be cos 30. Cos 30 is 147.15. What was it just now, Melanie? 147.15 correct?
Yeah.
147.15. So you find out that since the 30-degree angle is here, actually this should be cos 30. Yeah? Okay, cos 30, because cos is 150 over T1 bahkan. Okay, so, and not even 150, 147.15. Can somebody calculate T1 for me, please? Oh, you know what? This class got no meaning on somebody, so I must ask people. Brandon, can you tell me what is T1? If cos 30 equals to 147.15 over T1, what is the value of T1?
Is it 169.91?
Okay, 92 lah actually. 169.92, about lah. Okay, so it's not a very difficult this one lah. Okay, try to see how you can calculate T2. Since you know that we can use cos to calculate T1, okay, how can we calculate T2? And, sorry, after Brandon. So, Damir, can you suggest? Cuba kau cadangkan macam mana saya mau cari ini T2 ini. Apa yang saya perlu guna?
T1 square minus 147.15 square.
Oh, okay. I think that's also a very good suggestion. Boleh, you can use Pythagoras theorem to find it. Okay. Can you try and see? Damir, cuba kau cari dengan menggunakan cara itu. Okay. And Damir, kau cuba dengan cara itu, and I want to actually suggest that since I know this angle, okay, I will probably use sine 30 lah. Okay, tapi Damir, kau kira saja, then we can see if our jawapan is the same. So sine 30, okay, equals to, oh dear, this is so suffering, T2 over T1. Sebab kau sudah dapat T1 bahkan, which is, T1 is 169.919. Okay, newtons. So since I have T1, then I can calculate sine 30, and sine is opposite over hypotenuse. So T2 over T1. Okay, I can calculate this T2 lah. Okay, Elijah, can you calculate T2 for me, please? And then we'll compare it with Damir's cara yang dia menggunakan Pythagoras theorem, which also can actually. I think you will get the same answer. But let's double check that. Okay, Elijah, can you count for me, please? T2 and Damir. Siapa yang duluan dapat, just cakap saja kau punya jawapan.
84.96.
Okay, 84.96 kalau kita guna cara yang ini. How about you, Damir? Kalau kau guna Pythagoras theorem, bolehkah? Menurut Elijah, jawapan ini adalah 80 berapa itu?
84.96.
84.96. Betul tak, Damir?
Betul.
Sama? Okay.
Sama.
And actually lah, kalau kamu mau, I know the textbook is teaching us to use the sine rule and the cos rule lah, which you learn in admets. Okay, also can. There are actually many ways you can answer this lah. But if this is a 90-degree angle, okay, if you know that now our first situation lah, dia punya angle is 90 degrees lah. Okay, boleh kamu pakai sine, you can use Pythagoras theorem. So we use the sine rule or the cos rule that you learn from admets if the triangle is not a 90-degree triangle. Okay, so this is the important thing. So two things from this example. Number one, you need to know how to draw the equilibrium triangle. Okay, the equilibrium triangle is a different triangle from the resultant force triangle. Resultant force triangle is one arrow like this, then one arrow bersambung like this kan, and then the resultant force is this one. Okay, notice that the directions of the three forces kan, dia berjumpa di satu tempat. Manakala the triangle of forces kalau equilibrium kan, dia bersambung ni. Macam dia main kejar-kejar. Okay, do you see that? Two different situations. This situation yang kamu belajar in our first subtopic is to find the resultant force. Totally nothing to do with today's subtopic. Okay, because the way to draw that triangle is very different, and we have covered that. Today's work is talking about equilibrium of forces, and the number one thing that you need to remember is if all the forces are equal, all the forces can form a triangle that are chasing one after another. Dia macam mengejar satu sama lain. Okay, it goes in a loop. Okay, very important thing. You need to remember this. Okay, so let's take a look at this situation. Oh, this situation is the same as just now. Okay, so dia macam ni lah. Okay. So I'm going to skip this. Okay, let's talk about this situation. Okay, so question A, the three forces are in equilibrium. So force 2 is orang yang tarik di sini. Okay, so this is F2. Okay, and then this over here is this girl yang tarik dengan F1 lah. Okay, and then of course, since benda itu tergantung di udara, there's always going to be a weight downwards. Okay, now guys, if this thing is di udara, there is no reaction force sebab dia tidak menyentuh tanah. Reaction force is only if they are touching a surface. Dia tergantung di udara, so dia memang weight sahajalah. So the three forces are in equilibrium. Okay, so what is the resultant force for the three forces? The answer will be obviously 0 lah. This one no need to think one. The moment you see equilibrium, kau kena ingat resultant force is 0, automatic. Now, this is where I want you to put on your thinking cap. If this angle and this angle is 60 degrees, 60 degrees, I want you to flip over to your whiteboard and draw this triangle to show the equilibrium of forces for the three forces. Okay, take a look at this diagram and then flip over to your whiteboard to draw the triangle, and then I will check your whiteboard and see. Yeah, you have to rub off your whiteboard, everybody. Okay, everyone, let's turn back to our screens. Okay, so I'm going to show you. Think about, as I said think about the three forces, right? As kamu boleh tarik sini sana. The only important thing is the direction of the force cannot move. And usually, it is always easier to start with the weight force because the weight force is up and down. It's always the sengit force yang selalu mendatangkan masalah. Okay, so the weight is going downwards, and then after that, you can either choose to go left. Okay, if you go left means you're going towards F2, or you can go to the right lah. Okay, go to F1. In this example, they are going right first. Okay, they're going to draw the F1 first. Okay, so this is the F1. And then after that, they're going to draw the F2 to make sure that it is a complete loop. So W, F1, and F2. Okay, if you want to draw this way, if you want to draw this way and then this way, also can, Okay, you draw F2 first. Here is F2 lah, obviously. Okay, and then here is F1. Boleh, also no problem. Okay, so either one of these triangles is correct. Totally no problem. Okay, cuma our problem is always the angle lah. Alamak, the angle is not shown. Okay, so if this angle is a 60-degree angle, so actually here is 60 degrees. That's all I actually wanted to see lah. I wanted to see one angle only. Because if I have one angle, I can find the rest lah. Okay, I can find the weight and I can find the distance by using sine, cos, tangent rule. But sine and cos rule, which for now we're not focusing on that lah. Today I really want to make sure that you can draw the 60-degree triangle. Okay, so what about this angle? Okay, actually I don't know what is this angle, but I can actually count this angle. Okay, if F2 is here, okay, and W is here, right? I can actually count. Oh, sorry. Oh, I can't yet lah. I can't yet. Okay, but try to make it a point lah. Okay, whenever you have a triangle of equilibrium of forces, make sure you put at least one angle inside. Okay, because once you have one angle, you can count the rest one. Okay, that's the point of today's exercise. Okay, let's try this situation now. Okay, a box is stationary on an inclined plane. Stationary means it is in equilibrium. Dia tidak bergerak ke atas, dia tidak bergerak ke bawah. All the forces are equal. Okay, so, and I want you to draw for me the same thing, the triangle over here. Only now we know that this angle is theta. Okay, so you don't have to find out, you don't have to tell me the value, but you have to tell me in your triangle, where is the position of theta? Okay, can you give this a try and try to draw on your this one? This one is, I think, quite simple. I think so. Okay, so let's come back to the PowerPoint, people. So this is how I would draw this lah. So I'll take the W and I'll put it next to the R. Okay, and then of course I'll put the FR right over there. So this is probably the simplest one lah. Okay, so you have the W over there, and then you have the FR over here, and you have the angle. Okay, the theta will actually be over here. This is an easier one lah. Okay, and as you can see from the sort of animation in the PowerPoint, it's really just moving the stuff around. Okay, macam Iron Man lah. You know, you have this display in front of you. You just and then okay, see if you can find the triangle. Okay, this is also the same situation. Okay, W to the bottom and then F over there. Okay, except that just terbalik lah. And then since this is a 30-degree angle, which is the same as this angle, okay, so the 30-degree angle will be, okay, so a different day lah, we talk about this. All right, let's talk about this now. So you have, same thing, okay, this is sketching the triangle. Our work today is just Lucas triangle. So you have the way downwards, okay, you have this tension. I'm going to call this T1 and I'm going to call this T2. Okay, they're the same length, okay, cuma different direction lah, okay. The angle is theta. T1 equals to T2 because they are hung by the same string. Everybody knows this kan. If this is a picture, then you hang on a string kan. So you have the same tension lah. Okay, can you try to draw the triangle of forces on this one? Show me where theta is. That's the important thing. Okay, where does theta go? Or do you have to calculate something else to find the theta? This one is slightly challenging, okay, but I want you to give it a try. Okay, right, let's come back to this. So, same thing, we start with the W, it's always the easiest force, and then you bring the T1 across. Okay, some of you did T2 first, which is totally fine. Okay, I'm just giving you one alternative if I bring T2 across like this. Okay, so this is W, this is T, and this is T. Okay, now this is this animation got mistake. Actually, there is a line over here lah. So this is theta. Okay, and there is another theta over here also. Okay, which makes this whole angle, actually, this whole angle is 2 theta. Now, some of you, what you did was you drew a line over here. Okay, and you know that the line, the angle between this T1 and this line is theta. And since this is a 90-degree angle, this angle over here will be 90 tolak theta. Okay, and that's actually what I wanted to see lah, 90 minus theta. Okay, that's actually what I wanted to see. Okay, so yeah, same thing lah, this one, okay, W, this one, so I just want to show this again. Okay, now we talk about a container ship being pulled by 2 tugboats in uniform velocity. Okay, so you have one boat over here tugging with T1, I'm going to call this upwards T1, and then this one downwards T2, okay, the tension lah, and then there's a resistance, water resistance to the back. Okay, but because it is moving with a constant velocity, means that there is 0 acceleration, means that the forces are in equilibrium. It is moving, okay, but the forces are in equilibrium because they are moving with uniform velocity. Okay, so draw the triangle. Once again, draw the triangle. Today, everything is draw the triangle. Oh no, my goodness, we are almost out of time. Okay, so anyway, sorry, coming back to this. So we put the R to the left is the first, and one alternative for this will be to put the T2 downwards lah. Okay, so, and then you put the T1 upwards, and after that, what happens is you will have Once again, they never show you the angle. Okay, so actually that's it for today.